Hi children, today let us start with a new chapter. The chapter is related to acids, bases and salts. Already we have come across these terms. We have been telling sulfuric acid, nitric acid, hydrofluoric acid. These are all mineral acids. We call them as mineral acids. They come from mineral sources. We have a lot of acids which we use in our day-to-day situations or as a part of our food. They are natural acids. Attend to the difference. Acids, mainly we can divide them into two classes. Acids that come from minerals, we call them as mineral acids. Acids that come from natural substances are natural acids. Let's take a few examples. We prepare nimbu sharbat, lemon juice from lemon. It is sour in taste. We add sugar to it, mix it well. Lemon juice is quite refreshing. It's sour in taste. It's sour. It is a natural product. In the same way, you have buttermilk. It is lactic acid. Lactic acid is a natural product. Tamarind fruit. Many of these fruits which are sour in taste, they all come under acids. They are not very powerful acids, strong acids. They are weak acids. They are all natural. On the same lines, we have bases too. Bases, they almost stand opposite to acids. In their characteristics, they stand exactly opposite to acids. We will go through that today. The best example that I can take to start with is the soap we use to clean our skin, body. Soap. Soap has sodium hydroxide in it. That's why when you rub soap on your body, on your skin, put some water and start cleansing, you get the soapy touch, you say. It's slippery. Your hand finds it very easy to move from one point to the other. It slips, it slides. Bases are soapy for touch. They are slippery. On a soapy floor, it is difficult to walk. If you are cleaning the entire floor, applying soap, you find it very difficult to move from one end to the other. You slip, you fall down. Small kids, you tell them not to come inside at all. So, soap is slippery. We slide easily on soap. Many times you might have found the soap in your hand which you are using to cleanse your body. It slips out of your hand. Your grip, it falls down again, you pick up them. However careful you are, slope slips out of your fist. If you hold it tight, chances are more it slips. Should be very casual in holding it, careful at the same time. Acids, bases. You can't by heart all these. You have to take interest, understand and learn. When an acid reacts with the base, salt gets formed. I told you that equation already. Acid plus base will give you salt plus water. A general equation to be remembered. Now let us try to make a table wherein we distinguish between acids and bases. I have drawn a chart here, acids versus bases. The first one we already discussed just now. Sour taste. Maybe buttermilk. Buttermilk is lactic acid. Lactic acid. Or citric acid. They are sour. Buttermilk is sour. Lactic acid is sour. You put tamarind to the sambars you prepare. Tamarind. It makes the sambar a bit sour. Good. It tastes good because of the tamarind we have added. Bases, they have a bitter taste. As you take bath, you apply soap on the face. Chances are there that soap slips into your mouth. How do you find it? It is bitter. The taste is bitter. Opposite to that, acid. So bases are bitter in taste. We'll come to the next. See, acids, if you subject them to a test, it turns blue litmus into red. I have already explained to you in the beginning of this period. Acids are like water. For touch, only from that viewpoint I am telling. We should not touch concentrated acids. We may burn our hands. We should keep away from concentrated acids. I am speaking only of the kind of feeling you get when you touch an acid. A diluted acid, if you touch it, we feel it just like water. There is no difference. But when it comes to the bases, we feel soapy and slippery. I give you the example of soap solution. Fourth one, acids neutralize bases, whereas bases neutralize acids. Just the opposite. That means acids and bases react with each other, giving us salt and water. In the previous chapter itself, we had written down that equation and we had studied the general equation. Acid plus base gives us salt plus water. Very important, it's the fundamental rule that we study in chemistry. Acid plus base gives us salt plus water. We will go to the next. Neutralize, you understood. Neutralization means the characters, acids lose their characters. They turn to normality. Acid plus base, what you get is salt. Salt is neither an acid nor a base. Salt and water. Or you can say it's a solution of a particular salt. Next. Acids corrode metals. Most of the metals. Copper, aluminium, zinc, magnesium. All these metals, they get corroded by acids. Iron, especially if you keep iron with acid, iron gets rusted. It gets corroded. Easily it gets corroded. Acids eat the metals. In a simple language, if I have to say, people say acids eat metals. You can't have a metallic bottle in which you can pour in acid and keep it. The bottle itself will give away. You need a glass bottle. Chemicals we usually keep in glass bottles to prevent any possible reaction taking place. Another advantage, you can see what is there in the bottle right from outside. Bases. Bases do not corrode metals. Soap will not have any corroding effect on metals. You may have a soap box made out of a metal. It won't undergo any change. You can use it for years. So bases do not corrode metals. Now coming to the potential of hydrogen in the chemical. pH, we call it as pH in abbreviation. P stands for potential, S stands for hydrogen. We will be studying it in detail maybe in the next 3 or 4 periods. pH is less than 7 in the case of acids. pH, the measuring scale, is the range that extends from 0 to 14. 0 to 14. It starts from 0, ends up in 14. And the central point is 7. Less than 7, they are all acids. If it goes beyond 7 up to 14, they are all bases. 7 is neutral. Distilled water is neutral. If you try to find out its pH, it reads it as 7. Milk is usually 7, but milk undergoes transformation. Milk turns into buttermilk. The moment you keep a glass of milk in the open, it starts undergoing a change and starts turning into buttermilk. Say in a span of 8 hours or 10 hours or 1 day, the entire glass of milk what you had kept there would have turned into buttermilk due to fermentation. Now buttermilk, it is an acid. Lactic acid we call it. Here pH is more than 7. I told you. Once you cross 7, 0, 1, 2, 3, 4, 5, 6, 7. 7 is neutral. From 7 onwards, from normality when you move towards 14, you have all bases there. So pH of the bases will be more than 7. pH of the acids will be less than 7, 0 to 7. Next, phenolphthalein. Phenolphthalein, it is colorless. This phenolphthalein, it is colorless. Now, in acids, it remains colorless. You don't see any change. You don't see any change. Let's see now. I have taken dilute hydrochloric acid here. I add a few drops of phenolphthalein. Keep observing. Find out whether there is going to be any color change. There is no color change. Now, we will try phenolphthalein with a base. Sodium hydroxide. See the beauty now. I will add a few drops of phenolphthalein to sodium hydroxide, NaOH. NaOH is a base. See the change. The colorless sodium hydroxide solution turned into pink color when a few drops of phenolphthalein were added. So that's what is written here. Phenolphthalein is colorless in the acidic medium. In the basic medium, phenolphthalein turns into pink. You have to remember, this is one of the tests to find out whether the given solution is an acid or a base. See children, phenolphthalein is a mineral indicator. It's an indicator. It can tell us whether the given solution is an acid or a base. It is from minerals we get phenolphthalein. In the same way, one more mineral indicator is here. It is methyl orange. In the coming videos, we may use that too. Methyl orange turns to red in the presence of acids, but it will be yellow in color with regard to bases. So methyl orange is also an indicator. It is a mineral indicator. Then you may ask me, what are natural indicators? Turmeric, what we use in our house, is a natural indicator. Turmeric. In different media, turmeric changes its color. You might have seen your handkerchief, a beautiful new white handkerchief. A drop of sambar falls on it. A drop of sambar makes it a dirty. You don't feel like using that handkerchief anymore because there's a small yellow patch. You go and put it in running water, then apply soap on that because you're very eager to remove that stain. But you'll be perplexed to see that the stain would have turned into orange or red color now because there's a reaction that has taken place. Sambar is an indicator. Sambar is an indicator, it undergoes change. Depending on the medium what we are using, you use soap. It's a basic medium. In the basic medium, substances in sambar, what have been added, they act as indicators and they say we have been treated with the base. So they give a strong color. You get worried, oh, I should not have applied soap. Actually, when you remove a stain like that, you should not use soap. Instead of that, rub it well and wash it again and again in water. Don't use soap because soap turns the water into a basic medium and the indicator gives a darker color in the basic medium. That color won't go. Permanently it will stay on the handkerchief. Okay, that's something quite interesting. We come across a lot of such situations in our day-to-day life. So, we have discussed about the indicators. Cabbage, color cabbage, it's an indicator. Color cabbage. Some of these fruits, when they fall on our shirt and all, we get a particular color. You should be very, very specific before you apply soap. The best thing is to wash it under running water as well as possible. Then you see what you can use to remove the stain. Now some common acids we'll see. Lemon juice, I call it citric acid. Lemon, orange juice, these are citric acid. Soda, carbon dioxide has got dissolved in water. Soda. Coffee, caffeine is there. Caffeine, it's an acid. Tea, coffee, tea, theine. Tannic acid is there. Tannic acid. So they render coffee and tea to be acidic. So when your stomach is upset, usually you do not drink coffee or tea. Tamarind. Tamarind is tartaric acid. Tartaric acid. Vinegar. Vinegar is acetic acid. Acetic acid. Then you have battery acid. It's one of these acids which is said to be very strong. Battery acid is very strong. In vehicles we do use battery acid. So here common bases. Soap, a common base. We use it every day for cleansing purpose. Deodorants. Deodorants you apply, they are all bases. Fertilizers which are used in the fields, in farming, they are all bases. Drain cleaners, they are bases. Baking soda, it's a base. Baking or washing soda. Then bleaching powder, it's a base. Sea water, we call it as brine, B-R-I-N-E, brine. It's salt solution, brine is a base. So these are the key differences between acids and bases. Don't worry much. As you go on working out the problems in chemistry, learn more of chemistry, automatically all these concepts will get strengthened. Read a few times, try to understand the concept behind each of these statements. Okay, now we will move on to another important concept today as regards the reaction of metals with acids. All metals, they do react, almost all metals, they do react with acids. Metals do react with bases too, that I will not take up today. Let the concepts do not get confused. We will attend to reaction of metals with acids. So what is it we will take? We will take zinc granules and dilute sulfuric acid and see what reaction we do get. We will go stage by stage now. I mentioned them here. Zinc granules plus dilute sulfuric acid. The resultants, we will look into that part later. How are we going to carry on with the experiment? See, we have taken a conical flask here. You can take a conical flask or you can even take a long, strong test tube, or you can take a flat bottomed flask. So we have taken a conical flask here. In this conical flask, let us take dilute hydrochloric acid. We have dilute sulfuric acid in the conical flask. It is shaped like a cone, that's why we call it a conical flask. You are getting used to all the lab appliances. To this we will add zinc granules now. Okay. Now keep watching whatever happens. A rubber stopper, we have fixed it. From there we have a delivery tube. And in this trough, glass trough, we have taken soap solution, water. To that water we have added soap powder to make it a soap solution. To bring down the surface tension, we have added soap solution. It takes a few seconds for the reaction to commence. You see the granular movement there. The solution, the chemicals are getting restive. The moment you find the gas coming out here, you see the bubbles. And now there is more reaction. See, the reaction is taking place. Dilute sulfuric acid is acting on the zinc granules and hydrogen gas is getting liberated. You can see hydrogen gas getting collected over the soap solution in the form of bubbles. You see a lot of bubbles here. And minute by minute you see number of bubbles just going on increasing. Gas is coming at a fast rate, quite a fast rate. We'll check it now. See what happens when I take the candle, burning candle near the bubbles. A big explosion. A big explosion. What's it due to? Hydrogen gas is inflammable. Inflammable. It catches fire. Catches fire. You saw the explosion. Let me try it again. It is a beautiful experiment where you generate hydrogen gas and test the hydrogen gas. You might have understood now the reason why we added soap powder. The soap powder what we added has enabled us in getting hydrogen gas collected in the form of bubbles. They are not air bubbles, they are hydrogen bubbles. They are hydrogen bubbles. Hydrogen doesn't have any color. Colorless gas. See, quite a few bubbles are there. Shall we try it again? Wow. Quite a huge explosion. We will have an ultimate try. With that we close. Bubbles are making a sound as they get formed. You can even get the hydrogen gas collected in a jar. You can fill water in a jar, invert it over that. You should have a hive on which you place it and collect it by the downward displacement of water and test the gas. Yeah, we wind up here. You all must have understood and appreciated the experiment. It's a beautiful, rejoiceable experiment where we see hydrogen in action. Hydrogen is inflammable compared to oxygen. Oxygen helps burning. If there is fire, oxygen makes the fire burn well. Fuel is required, without which oxygen will not burn. Hydrogen doesn't need fuel. The gas itself will catch fire and burn. We don't have any fuel here. The gas caught fire directly. To tell you, sun is made up of hydrogen. Sun is full of hydrogen. But all the hydrogen cannot get emptied because you don't have oxygen on the sun. Hydrogen, as it burns, it takes oxygen from the air. But on the sun, you do not have oxygen at all. It's just a hydrogen sphere, a huge sphere of hydrogen. Okay, we will not move on to that. Let's see here. Metal, you are not to forget now, metal plus acid or acid plus metal gives us salt and hydrogen gas. A very important concept to be remembered. Now, let's take a few examples for acids and bases. HCl is hydrochloric acid, H2SO4 is sulfuric acid, HNO3 is nitric acid, Ca3COOH is acetic acid. Now here HCl, H2SO4, HNO3, these are all mineral acids. But coming to citric acid, lactic acid, tartaric acid, all these are natural acids. All the acids you get from fruits, they are all natural acids. They are weak compared to the mineral acids. So that's about acids. And here you have bases. Lactic acid is buttermilk. Buttermilk is lactic acid. NaOH, sodium hydroxide. Potassium hydroxide, KOH. Calcium hydroxide, CaOH twice. MgOH twice, magnesium hydroxide. NH4OH, ammonium hydroxide. All these are bases. In bases you find OH, remember it, OH. One oxygen atom and one hydrogen atom together, it makes a molecule of hydroxide, OH, hydroxide. In acids you find H, only H. You don't find O here, H you find. H is the key factor here. Here, OH is the key factor. In all bases, you find OH. In acids, mainly you find H. Then when you move on to organic chemicals, you find certain differences. That's different. We'll study them separately. So remember the names of these acids and bases and their formulae too. We close it here. Thank you.